3D printers are appearing everywhere. For example, medical researchers have printed tissue-like body parts, including a human ear. And custom dental restorations can be made in your dentist's office instead of sending molds to a lab. Everything from new prototypes to obsolete replacement parts has been printed for use in vehicles, aircrafts, robotics, and more. Even artists and jewelry designers have embraced 3D printing technologies. While the applications vary dramatically, 3D printers share one common characteristic. All items are created by building layer upon layer of material. So how do you print a home? The term 3D printed house is misleading because printers don't create the entire house. Currently, they are only used to erect exterior and interior walls and to build foundations. Once the printed components are complete, various contractors tackle the rest of the house, similar to how stick-built homes come together. Trusses and roofs are installed, windows and doors are framed, mechanicals are run, and flooring, appliances, and finishes are added. Even though printers are only used to build essential structural components, they can complete this step faster and offer other benefits over traditional building techniques. There are two types of printers. Gantry systems are hung from an overhead framework. It takes time to set up the system, but the entire building can be printed once the components are positioned. In contrast, robotic arm printers are smaller and more portable. They can only print one segment at a time, but typically with finer details. Most 3D printed construction relies on concrete. Suppliers develop proprietary blends using additives to improve strength and optimize drying time, so subsequent layers can be printed quickly and without forms. Concrete is desirable for its strength and durability, but it is not an environmentally friendly product. According to the Global Cement and Concrete Association, cement production alone represents 7% of global CO2 emissions, 3 times the emissions from aviation. But builders recognize the importance of making their products more sustainable and are taking steps to limit the amount of concrete needed in 3D printing formulations. Designs are also being modified to reduce the required concrete without compromising strength and structural integrity. Beyond concrete, other materials used in 3D printed construction include glass, clay, and plastic. So how quickly are 3D printed homes taking off? Printed residential construction is still a novelty, but it's easy to find examples of single-structure projects worldwide. For example, Austin-based Icon built its first 3D printed home in 2018. The company is breaking ground on a 100-home Austin neighborhood in partnership with Lennar Home Builders. In Virginia, Alquist 3D completed a Habitat for Humanity 3D printed home and subsequently launched Project Virginia, a 200-home initiative to help the state meet housing demand in its growing hubs for manufacturing and tech jobs. Beyond residential homes, 3D printing has also been used in commercial real estate, military, and beyond Earth, meaning how to build structures on the Moon and Mars. What are the advantages? For one, 3D printed homes are less expensive. When walls are built by printers instead of construction crews, the labor cost is dramatically reduced. Additionally, printers only use as much raw building material as necessary to erect the walls, reducing material costs and construction waste. They're faster. Once a 3D printer is positioned, it can operate continuously, frequently completing the walls within 24 to 48 hours depending on size and design of the home. They're energy efficient. 3D printed homes have thick walls, often with cavities where insulation can be added. This makes them highly comfortable and quiet and reduces heating and cooling costs. Design possibilities. Curved walls are expensive and challenging to incorporate into a traditionally built home, but it's easy for a 3D printer to execute unique design elements without driving up the budget. Durable. Concrete 3D printed homes are well suited to withstand high wind and extreme weather. They're also largely fireproof. And worker safety. Building homes can be a dangerous work, but the risk of injury is reduced if a printer erects the walls. What challenges and limitations are facing the industry? Barriers to entry. The cost of 3D printers will likely come down in time, but until they do, few builders are willing to invest in this expensive equipment and the skilled workers to operate it. Regulations. Since building codes are written for standard construction techniques, builders using 3D printers can face substantial hurdles before getting their projects approved. Lost work. Automation has its advantages, but can also result in job losses. 3D printed homes will require fewer workers, and the remaining jobs will demand specialized training. Permanent floor plans. When homeowners remodel, they may want to modify the placement of interior walls, but if those walls are made of concrete, it will be harder to relocate them. On top of sharply rising home prices, buyers are factoring inflationary pressure and higher mortgage rates into their budgets. So more than ever, we need practical and affordable housing solutions. Can structural 3D printing help fill the gap? It's too soon to say, but builders are making impressive progress. With strong backing from investors, 3D printing equipment and materials keep improving, and 3D printed housing developments are breaking ground.